Hello, sir.
Can you hear me? Can you hear me?
Yes.
Oh, is it loud enough?
Shall we wait for more students or just you two will join today?
No, sir. They both
No,
will
sir.
come,
I
sir.
will
I think.
join. On
Join now.
until 5:03 we wait, sir.
Okay, we'll wait for 2 minutes.
1 second, sir. I got changed internet. Come 1 second. எந்த பவர் பாயிண்ட் வர்ஸ் இல்லன்னு நினைக்கிறமா
Mute da.
What up?
I said to mute.
I didn't wear my
Hello, Kalpaj.
Hello.
Hello, Kalpaj.
Hi there. Sir still didn't join?
Sir is here. He's just in mute.
All of you joined?
Yes, sir.
Sir, Tarun has to join, sir.
Yeah, that's why we are waiting. 1 more minute we'll wait and then we'll start.
Sir.
What were we doing
Sir?
before the discussion of this test paper? What were we doing?
Sir, we just finished motion in, I mean, loss of motion.
Sir, and one more request, sir. Sir, one more request, sir. One more request, sir.
So can we do magnetism, sir? Because that's what we have for this
Yes.
terms exam.
Pardon?
So we don't
Can we
have
do
pressure,
magna-
liquid
ma-
and this thing.
Shh,
Wait,
Sankalp.
I'll tell you. So we don't have the chapter you're just now taking, the pressure in liquid and atmosphere. That one we do not have this term. We have a magnetism in the last chapter.
Can we do magnetism, sir?
But the thing is that I've started this chapter and more than 25% is completed.
But we don't
Okay,
have
sir.
magnetic
We'll
stuff,
do.
sir.
Can you see me clearly?
So me and
Yes, sir. We
Nitish
can
just
see your
felt
video.
like if you would have taught magnetics, it would have been better, sir, because we would have
You
practice
should
for
have
our
told me
exam
earlier
also.
now,
Because
because
So now,
what has
Sir,
happened?
we didn't know,
today only
sir.
they started, sir. Today only they started.
we didn't know, sir. Today only we started this chapter.
Like, are they going to ask some kind of test, like for test in school?
No, sir.
Exam,
Exams,
sir.
the first term
No,
exam.
no, sir. Our exams are starting. Our exams are starting in like 10 more days, sir. Physics is the
They're
first
asking for
exam.
magnetism, and they're asking for magnetism.
Yes, sir. So it's the second chapter, motion in one dimension, laws of motion and magnetism.
Yes, sir.
I'll have to talk to this administration then. You should have told me earlier.
We didn't
So
know,
they
sir.
told
Today only
today
ma'am
only,
taught.
sir. They just started it today.
They have taught magnetism.
No, sir. They're now only teaching. Like they
So how will
started
they ask in exam if they haven't taught that?
like exams in there next week, so the day after the week, sir. Or the week
Magnetism
after
is the last chapter that I can see in my notes.
Yes, sir.
Yes,
They
sir.
skipped
Yes,
all the
sir.
chapters
Magnetism
and
is the
then
last.
did
They skipped all the chapters and went to magnetism, sir.
and like after next term we'll do the other chapters and do so.
See, 3 more classes are required to complete this chapter. Can you wait till that? Yes or no?
Yes.
Like,
Yes,
I'll
sir.
be completing this chapter in 3 more classes.
Sir,
And
yes,
after
sir,
3 more
but
classes, I
yes,
can.
Sir,
the
today
week after the week
is
as exam.
July 5th. July 5th, sir. So we next week we will have 2 classes. And Friday, do we have class, sir?
See, there is some. Actually, the thing is that now, what happens? There is some proper algorithm. Okay, there's a proper algorithm that we go through. They ask me, the administration asks me about the chapter, what I'm going to start, and then I give it them the chapters that I'm going to start, and they prepare the questions accordingly. The test papers, the DPPs have been prepared like that. So I'll have to talk to them, or what you can do, you can talk to them to get arrange some extra classes. Then I can help you.
Okay,
If you
sir.
can
Okay,
talk
sir.
to them. Because you should like I am even I know that is the kind of problem if they have started with that chapter and they are going to ask that thing, and this is of no use now. I know that, but the thing is that if you would
Yes,
have
sir.
told me just previous class that we started, I would have said that I'm going to start magnetism. But
So
now
Yes,
what
on
will
sir.
happen?
We
I'll
didn't
have
know
to
that.
change all
Sir,
the authority.
excuse me, sir. So on Fridays, can we have an extra physics class, sir?
I can be available for you, but you have to talk to this with your administration part. You all have to go and talk about this.
Yes, sir. We can replace the maths class of Fridays to physics because maths we are way ahead, sir.
Okay.
We're like 5 chapters ahead.
Yes, sir. In
I'll
maths.
what I can do, I can okay. I'll try to talk to the administration if I can change the chapter. Okay. I'll try to
Yes,
talk to
sir.
them. I'll talk to them today. Okay, and then I'll ask them about the thing. What can be the solution for this? And whatever they say, I'll ask you to do the same. Understood? Because nothing is there in my hand. There are few other blocks now. Some people check your paper, some people make the question paper, some people arrange the classes, and this it works like that. So actually, I cannot directly change this, because now what will happen, they'll share you the DPP of this your pressures, isn't it? This weekend they'll share the PPT of this the DPP of pressures, and you won't be able to solve them then, and then they'll be taking the test. So I'll have to talk to them. I'll have to arrange the things accordingly. Understood?
But aren't you the one who gives us assignment?
Pardon?
You're the one who
Yeah,
gave
let's
us
just-
assignment, right? So not them.
I am given the question papers, I arrange that and then give it back to them. They initially ask me whenever the chapter ends, they ask me what are you going to start now. So I'll have to answer them that this is the chapter I'm going to start for this particular month. So it goes like that. Understood?
Yes, sir.
So I'll talk to the administration today.
Yes,
Right.
sir. Or we can do another thing
Yes,
by
sir.
just going through this chapter very quickly and then like
What I can do. That's
start.
what I said. That's what I said. Including today's
No,
class.
sir,
I
I'm
need
telling we don't. I'm not saying like we have to finish this chapter. We can just go through this chapter like short, like very shortly, and after that we
They'll
can
give question
go
paper
to
now.
magnetism.
they
But
take
sir
proper
will
test.
give
They'll
the
give
questions,
question
right?
paper, no assignment.
Yes, sir, but they'll ask questions from you, right? You give us the simple questions. So the questions we know. Then we
Hey,
go
hey,
to the
hey.
magnetism.
See, I have the,
What is this, uncle?
I cannot
No,
deal.
sir,
I
Stop
I'm
cannot
saying
deal.
proving them
we
again
can
and
go
again.
through this chapter like very quick. We'll go through this chapter very quickly, and then again, if we like in term two, if we ever get this,
I'll talk to the
questions, we can.
administration. I'll let you know. I'll talk to the administration. I'll let you know.
Today we'll do this
Okay.
chapter.
Please follow here. Follow up here. I'll talk to the administration. When is the test? Tell me. When is the test?
So first test is July 17th, and that is our physics test.
So where this magnetism chapter is going to be asked? When is that test?
July 17.
Sir, like July 17th.
So we don't have
Sir,
any test from
17th is.
chapter, but we have it on exam.
We don't have tests separately on we don't have tests separately on magnetism, sir. We have like term one test
might
where
have-
all chapters are
Exam,
asked.
sir. A term one
On
exam.
17th, you have term one test, and what are the chapters that are going to be asked?
So it's
Sir, second
Sir,
chapter, third
first
chapter,
two
and
and last one.
magnetism, sir. Yes, sir.
Laws
This,
of motion,
motion.
and then yes, sir.
Motion in 1D. Laws of
Magnetism.
motion.
Laws of motion.
Magnetism.
Magnetism.
Magnetism, and then the first chapter, sir.
First chapter, I don't
If
think
possible,
we-
first chapter. If possible, first chapter, sir. If possible,
Measurement
first
and
chapter.
Yes, sir, if
experimentation.
possible.
Laws of motion and magnetism. That's all.
measurement and
See,
experimentation
Tarun,
is
if
like
it is
maybe
if possible, sir.
it helps them. Like this.
Okay, so let me complete this. Follow up here. I'll talk to the administration and then I'll let you know.
Today we'll do
I'll
pressure
talk to
and
that.
liquid chapters. Yeah.
I'll let you know. I'll let you know. Everybody look up
Today
here.
we'll do
So yesterday we did the pressures. Okay, we did till the pressures part now.
yes, sir.
Okay.
Yes, sir.
So what are the factors affecting pressure at a point? What is the pressure? So pressure
So,
on a liquid
pressure
at a certain depth of H,
will increase.
right?
Increase in depth.
Pressure is equal to thrust by
That was equals
area.
to rho GH, right?
Thrust by area.
Yes, sir.
We derived it. We derived it rho GH.
Yes, sir.
Agree?
Yes, sir.
Now,
Yes, sir.
what is the total pressure? You know, not only this water due to this the height, water at this height is acting on it. There is atmosphere also above it, which is being acted upon it. So total pressure
Yes, sir.
will be what? P. I can write it as P total. It's P atmospheric plus rho GH. Correct?
Yes, sir. Rho is density, right?
Understood? Rho is density. Yeah, rho is density. Rho is density of liquid. Density of liquid. So what are the factors on which this depends? Okay.
So then rho, atmospheric pressure, gravity due to acceleration, and height.
What was the question,
Factors
sir?
on
What was the question?
factors on which pressure at a point on liquid depends. First one is
Sir, what is that? P is equal to J G.
It's rho. It's
H,
rho
what is that?
density.
rho RH rho.
Oh, okay. Density into height.
No, it's
Density is to
density of
gravity
liquid
into height.
equal to rho.
Density into gravity into height. Sir, pressure is equal to thrust by area, sir. Right, sir?
So see here, see like pressure at this point will be equal to the weight of the liquid above it. Agree or not?
Yes, sir. Yes,
Yes,
sir.
sir.
So what will be the, let us say that rho is the density. Density into area into height, which is the volume. So density into volume gives you mass times gravity gives you weight. So this is the force divided by area. So this is the pressure rho gh.
Area and area is the pressure and then rho h.
Okay, okay,
Got it?
okay, okay. Yes, sir. I get it. I get it, sir.
So depth of point below
So can you,
free surface h. Second is density of
so
liquid.
you can just say height, depth, height and depth or something. Height, grams, no grams, height, gravity due to acceleration, rho, that's those are the factors of pressure, and atomic pressure. See, atmospheric pressure.
Understood, everyone?
Yes, sir. It's atmospheric
Sir.
pressure.
Atmospheric pressure is
Sir,
constant.
even
It acts
the
away.
Yeah.
sir, but the higher you go, the atmospheric pressure decreases, like changes, right, sir? The
Yeah.
higher you
So
go.
again, that is dependent on height now.
Okay.
It does not depend upon shape and size. Shape and size
How does it
of
liquid or
vessel.
shape?
Shape and size of vessel.
Oh,
Second
vessel.
thing,
Okay.
area of surface. You saw that area got cancelled. So area of
So
surface.
it does. So it is like it does depend on the size of the vessel, sir.
See here. If I take a vessel like this, I fill it to the height h. If I take a vessel like this and I fill it to the same height h, so pressure at this base will be same.
No, so but like it's got like for the second one, it's concentrated at one particular area where all
But we
water is
saw now
coming.
that area is not being, or like area is not creating any problem or difficulty or
Only the
whatever you
like
say. But
exact molecules
giving the
above
answer,
that
area is
Yeah,
single
given
point
there.
yeah.
gets like calculated.
Like see here,
So
what will you if I ask you that this glass is 10 centimeter fill, what formula for pressure will you write? You'll write sir rho into 10 into g. And if I fill the same
Yes, sir.
liquid rho and rho here for 10 centimeter only, you'll write the same rho
Sir,
hg only.
G is acceleration due to gravity, right? So that is also
Gravity due to
9.8, right?
acceleration.
So we can
It's
take it as
gravity
a
due to
constant, right? Sir?
not acceleration to gravity.
That is not a constant.
Not
I
So
told
it
you.
acceleration.
is
98.
9.8, right, sir?
Acceleration
No.
due to gravity is more at poles and less at equators. It depends on the position on the earth.
9.8 or 10. So like I am saying, we learned that pressure of a liquid like is applied on the walls of the container, right, sir? But if the walls is further apart, means the pressure will be less, right, sir? And it's more at the top. So because like when the pressure like pushes the okay, yeah, it's sort of okay. I take back what I said.
That's what I'm written everything here.
I'm writing.
Write it down.
Writing, sir.
Why all of you not switching on your videos? I cannot see your faces.
Yes. Oh, yeah.
Sir, I switch it on, sir.
Yeah, I can see. I can see yours.
The first point which I have given is depth of point below free surface.
Still there or not?
Depth of
What?
point below the free surface. Depth of point below the free surface h.
Yes.
Everyone.
Last diagram, sir.
Yes, sir.
Done?
Sir.
Yes, sir.
Yes.
Okay. Yes. Right. So there is something called laws of liquid pressure. Laws of liquid. What are laws of liquid pressure? First law says that inside inside the liquid, inside the liquid, pressure increases. Pressure increases with the increase in depth from its free surface. Okay. So you all know this. Inside the liquid, pressure increases with the increase in depth. If you go to a greater depth, the H will be more and pressure will be more, right?
Yes, sir.
In a stationary liquid, stationary liquid, pressure is same at all points on a horizontal plane. On a horizontal plane. So in a stationary liquid, like if the liquid is not moving, so if you take a certain height, let us say that if you take a certain height from the top, let us say we are taking the small height h, or we are taking this height h1, or we are taking the whole height h. So what is happening? At the small height, whatever point you take in this horizontal plane, the pressure will be same. At this height, in this horizontal pressure, the plane, the pressure will be same. At this height, in this horizontal plane, the pressure will be same. Understood?
So, but displacement.
Okay, can you repeat it again, sir? Can you repeat?
At a certain height, if you're taking water or liquid, any liquid in a container, and at a certain height, okay, from the certain depth from the top, I should say. So what will happen if you draw a plane? So water particles, liquid particles, like any liquid particle in that particular plane will be facing the same kind of pressure because all of them will be having the same
Yeah,
H,
but
rho g.
for different, sir, but for different liquids, the density is very different, right, sir? Then
I am taking a
how will it
particular
be same?
container. Now, how can you, in a particular container, how can you place different liquid?
They'll form layers if the density is different.
Exactly. See, if you're taking something like that, if you're taking, let us say that this is not visible, and this is not visible. See, if you're taking like densities, different densities. So what will happen? Let us say that you mixed oil, you mixed water, you mixed mercury. Okay, you know what will happen? Mercury will settle down at the base. Mercury will settle down at the base.
And water, and then above that oil.
Sorry.
Experiment, sir.
Then what will happen? Then water will be there. Water will be forming its layer.
Yes, sir.
Okay, and then will come the oil. So even now, if you calculate at a certain depth, so in that particular plane, all the particles will be having the same. Like in this plane, all the particles, all will be the same particles. Now, are you getting my point?
Yes, sir. Yes,
Even
sir.
if I mix three different kind of liquids there on the request of Sankalp, I mix three different kind of liquid, but at a particular depth, I'm taking this depth or I'm taking this capital H depth. In a particular depth, I'll be getting the same particles. Same particles means density constant, G constant, and H is also constant because I'm taking the particular height. So in a particular plane, the pressure will be same. Understood?
Yes, sir.
Yes, sir.
Next.
So I have a doubt, sir. So
Go on.
but when I place like an object in the water, it'll displace, right? So, but the pressure won't differ, right? Because it displaces and the water goes up, so there is no actual
The
pressure.
different thing we'll study later. That is buoyancy. We'll study later in this chapter. Wait for that.
Oh, so it's the code another chapter.
No, no, in this chapter itself at the end.
Yeah.
So if pressure is same, so what happens? Liquid applies pressure in every direction. For example, for example, let us say that you have kept a box, okay, and when you apply the pressure from here, what will happen? It will like apply the pressure in this direction and this direction also, na?
Yes.
It will try to expand
All
laterally. If you're
Yes,
applying pressure, compressive pressure will try to expand laterally. So same thing happens here. Liquid also try to expand laterally. It try to expand this wall. It try to
Because it doesn't
expand
have
the
a
wall.
definite shape.
If a particular at a particular height, the pressure is constant. So at a particular height in all the direction, in all the walls, you'll get the same lateral pressure. So in all the directions, about the point pressure is
But
same.
sir, but the pressure at the bottom will be more because in like when it's a different liquids, in the different liquids like where mercury is at the bottom and the
about
water.
that.
I'm saying at a particular level. I'm not comparing this level with this level.
This law is not
I'm
about
comparing
that.
this liquid particle with this liquid particle. That's what I'm comparing.
Same level. It's at the same level.
Yes, sir. I am saying in the bottom there is mercury. In the second there was in the middle there's
The
water, and in the
mercury-
top there's oil. The oil like exerts less pressure than the mercury, right? So because the density of the mercury is more than the
Yeah.
oil.
Yeah.
Okay.
Like if you're comparing different, then like pressure here and pressure here will be
Yeah.
different because H is different
But
and
the-
rho is also different.
But the top of mercury will exert less pressure than the bottom of not mercury. Top of oil will exert less pressure than the bottom of oil. Because they are the different level.
So what is the pressure at same depth is different in different liquids. That's what Sankalp said. Like even if we are taking a particular height H, and at height H in one liquid container it is mercury, in another liquid container same height H is containing water, a
sir,
third container is
you've written,
Density is
sir,
also
you've
like a
written
defining
it.
manner.
After it, what have you written, sir?
it increases with increase in density of liquid.
Oh,
So that's because density is a part of pressure, and that's called rho. It's a defining
Yeah.
property.
And
density
liquids,
is rho, right?
It's a factor.
yeah.
It's rho. It's
Yeah.
rho.
So write this down. We'll be moving further.
Done, sir.
Okay, let everyone complete. Everyone.
Almost there.
The last.
Sir.
What was that sound?
Came from Sankar, right? So yeah, I think everyone finished.
I think it was
Yes.
Kongweld. He sneezed.
Wow.
This was. Mhm.
Sir, done.
Yes, sir,
Everyone
everyone
done?
done. I think.
Yes, sir.
Yes, sir.
Okay.
Yes,
The next
sir.
point that we'll be moving to is some Tarun done.
Sir.
Okay. So there are certain consequences of liquid pressure. First of all is in seawater, the pressure at a certain depth in sea is more than that at the same depth in river water. Can you explain me why?
What did you ask, sir? I didn't hear you.
Sea,
Yes.
the pressure at
But sir, it's
certain depth.
because the area is different, sir.
Sure. He's telling the
No,
question.
should
Tell
not
sir,
talk
tell
to
sir.
like that.
Certain that. Sorry, sir.
Should not talk to your friend
Yes,
like
sir.
that.
Oh,
In
sir, I don't.
seawater is more than that at
Sir,
the
it's
same.
because seawater is mixed with salt.
Shush, Sankar. Wait.
Let me cover the
It's more
question.
than that.
Hmm. Answer this. The reason. Given the reason.
Yes, sir. I raised my hand first. So, this is because of the density of the water in the sea. Rainwater is just pure water, but then seawater has mixed salt in it, and also there's a lot of fishes and many aquatic life in the ocean that can cause
To
varying
go
depth.
to that extent, to just say that
Salt
the
impurities.
density of seawater is more than that of river water, and that's why the pressure at a certain depth is different, and instead it
I
is
not say
increasing.
river water also.
You were correct. You were correct. Okay, no problem. But this is enough. Okay. Next thing, who will answer this? Have you ever been to some kind of dam?
Yes, sir.
Dam.
I've been to a dam.
Some
I've
kind
been to
of
a dam.
dam.
Yes, sir.
Damn.
Which one? Which
I
one?
don't know.
I've been to
Sir, I've
Mettur
been
Which
Dam,
one
one?
sir.
in Kashmir, sir. Kashmir.
Okay.
Yes, I also seen it, sir, in YouTube.
Can you answer this one? Dams are made like
What
this, na?
happened today?
Dams are made like this.
Yes,
Now, have you seen
sir.
that?
Sir, I can tell it, sir. I can tell
Yeah,
it.
yes, sir.
I
Yes,
raised
sir.
my
They are
hand
the
first.
broader at the base. Ritesh, go on.
So I can tell it, sir.
Go on.
Sir, this is because we saw a law that pressure of liquid is more on the like bottom because it exerts more pressure with increase in height. Like pressure and height are directly proportional, and with increase in height, the pressure will also increase. That's why the bottom of the dams are
Exactly. In
thicker.
a dam, the maximum pressure is at the bottom. So to balance that, the wall of a dam is thicker at the
Thicker.
base. Got it? It is
Like
something
even
like
area
that.
matters, right? Sir,
Hmm?
because like if we keep increasing the area, the pressure decreases while coming down, right? So because we divide it by pressure is indirectly proportional to area.
No, area is not even depending on.
But the area is constant now. The area in which you can draw you can make the dam, that is constant now. How can you increase or decrease?
Sir, it's only bigger, so it won't
So
break by the pressure of the dam, sir. Like the wall won't break. Like make a
okay.
hole and go. The water will go.
So size of gas bubble
Yes.
formed in water
Normal bubble drain, sir.
grows in size as it rises. So have you seen water bubbles inside water
Yes,
Yes,
sir.
sir.
that contains
In soap water.
air, isn't it? So there are gas bubbles which contains air, and they are small at the bottom, and when they rise, na, they becomes large. Can you tell me why?
Because of atmospheric pressure.
What is this? This is a random.
Like no, the atmospheric pressure is decreasing with increase in height. So the pressure exerted on the bubble will decrease, so
It's liquid
it has
pressure,
ability
not
to.
atmospheric
Atmospheric
pressure.
pressure is constant at all places. So
Sure,
actually,
but
what
still
is
it's
happening there?
with
Liquid
heat,
pressure,
right,
the
sir?
depth as it is rising, the depth from the top is getting decreased. So that rho gh is getting decreased. Are you getting my point? That rho gh is getting decreased. So pressure decreasing, it is expanding. Got my point?
So that's what Nitish
But
Yes,
told.
sir.
sir, but
See,
atmospheric pressure decreases
you
with
told
decrease,
about
right, sir?
atmospheric pressure. See, atmospheric pressure. See here. What is happening there? Let us say this is
Atmospheric
this.
pressure constant, sir.
This is surface.
Sir, his answer was quite the same.
So
See,
how
this is
is
H1.
atmospheric pressure constant, sir?
Tell me, I'll tell you.
Hey,
Please wait here.
Nitish, you go like deep into the ocean. You like contract, right? But when you come
See
up,
here.
like
See here. See here.
your
See
body
here.
feels a relief,
If you
right?
want to write
Above
the
the
pressure
water.
here, this is
Inside
P1,
the water.
P2,
Oh,
P3, P4. If you want to write the pressure P1, what will you write? PATM atmospheric plus
sir.
rho GH1. If you write P2,
Yes,
it
sir.
is PATM plus rho GH2. So what is varying here? This PATM
Sir,
plus rho
Right,
GH3.
right is
So this
decreasing,
H is varying, na?
sir, the
sir, you could have
Atmosphere
told me
here,
it's
atmospheric
underwater,
pressure here is
sir.
constant.
Sir, there's one big black. Okay,
yeah,
wait.
it's gone.
What happened?
Sir, nothing, sir.
Nothing, sir. There was
Sir,
one
you could
black
have
screen.
told me the bubble was inside the water, sir. I thought it was like in the air, sir.
Inside the
How can
water,
a
how can you
bubble
think
form in
that?
the air, Dad?
Then what do you
This is
mean,
inside the
sir?
water
What about the
only.
bubble toys and all that?
No, no.
Oh,
Write this
No,
down,
no
and after
bubbles.
this, I'm
Sir,
going
you
to
could
teach
have
you
said
something
no
interesting.
bubbles, sir. Why gas bubbles, sir?
Write this down. After this, I'm going to teach you something interesting that you may
Yeah,
have
note
seen
it
that.
down, sir. So
Yes,
what do
sir.
you mean
This
gas
is
bubbles, sir?
everything
Isn't
we
it
learned.
air bubbles, sir?
Haven't you seen small bubbles?
Yes, sir.
yes,
You
sir.
said it
Yes,
is in
sir.
water, sir.
Those are air bubbles, na?
Air bubbles also are
Write it fast.
water bubbles, sir. So, but my answer is correct if the bubble is like above water, right, sir? Like in the normal
Day.
water. What?
Hey, sir, it's not even there.
He just muted. It's there only.
I'm here. I'm here. I'm just mute.
Yes, sir.
I
I'm
mean,
telling, sir.
you're
Like,
there.
my explanation was correct when the bubble is like not in water and above water, right, sir?
You said na that the pressure is changing due to the atmospheric pressure term, but the thing that
Yes,
was
sir.
changing,
It's
it
wrong,
was
sir.
the, yeah, your concept was correct. Your concept was correct. That you were like you said that somebody joined. Okay, you said that the pressure is changing due to the atmospheric term, but I said I just wrote it down there. I described that it is not the atmospheric term that is changing. It is the pressure due to the liquid column that is changing. But yeah, you said it
Yes, sir.
correct because of the change in pressure. Because of the change in pressure, it was changing. So that is correct. But it should be exact. In science, now you should be
Yes, sir.
having the exact answer
Sir,
because it is
even
not
a
like history.
water bubble. Sir, even a water bubble, how can it change, sir? It maintains the same
Can you
height,
form a
right?
water bubble in water? How can you form a
Sorry,
water bubble in water?
I mean a normal bubble, the thing.
Bubble.
Is the air bubble or
Soap
gas
bubble.
bubble?
Air bubble.
Soap bubble contains what?
Air bubble.
What is there inside the soap bubble? It is air, na?
Sir,
Yes.
it's
Yes, sir.
sodium stearate.
Day.
No,
That's soap,
that
bruh.
is
Nobody
that is.
asked.
So that
Oh,
is what
sir,
point.
so
You
it's
don't
is
get
it
you don't get confused with gas bubble. Gas bubble is the same bubble that you see because that contains air.
It's a normal
so
air
the
bubble.
air inside the soap bubble which we blow, that it like it puts a pressure to all the sides, and is that why it expands? Is that what Nitish said?
No, I didn't say that. See,
Sir
Pardon?
just
so
gave the
I'll explain, sir.
explanation.
I'll explain. So see, when the bubble is going up, you know, atmospheric pressure is indirectly proportional to height, right? When height
Liquid
increases,
Yes.
pressure.
It's not atmospheric pressure.
he asked outside water, da.
They
Oh,
are
outside
outside
water.
water. I'm asking outside water.
Okay, my bad.
Inside water, the atmospheric, the column above it, whatever is there above it, if it is
Air
decreasing,
column.
the pressure will decrease. Okay,
But it will
I'll
never
share.
go up, right?
Have you ever been to car wash?
Yes, sir.
Yes, sir.
Sir,
That
Like
spinny thing,
what
like
they do? what they do?
The
They pick up your
springs
car
are-
They
like this,
put
na?
the yes, sir.
Put the
Oh,
car
that
in
format.
some lift,
Or
na?
like
And then
So
they
while
wash
is
from
Thomas
this
below.
is at
Yes, sir.
home
in
at
like
night, so he
big
likes watching.
Yes,
stores?
sir.
This car parking also like that.
Seen that?
Yes, sir. Yes, sir. They use
So
the
have
jack
you ever
jack.
imagined that how do they do that? Like car weighs around 1000 kg, 500 or 1000 kg. It is the
Hydraulic.
weight of the car is. Okay. So how? Yeah, hydraulic pressure. That's very
So
good. So what do you mean by hydraulic pressure? So can you imagine that
Normal
how much
reaction
pressure?
force, but
What
with
machine
more
will be required
reaction.
to lift that
I
car?
have answers, sir.
So it's a
Pressure,
hydraulic like
sir.
lift.
No. Okay,
Yes,
yeah,
sir.
that's also a good thing. Sir,
They use
I
the
am telling.
Pressure, sir.
they use the compressibility of liquid as an advantage. Like it doesn't compress, so it can handle any weight. So they use it to lift.
Very good.
Sir,
Nice knowledge.
another thing, sir. Like it's a
Yeah.
totally different topic, sir. Because the force of contact is very less. So when you use like a jack hammer or jack thing, and then it'll be easier for it to
Jack
the
thing.
pressure acted on the body when the area is less, the pressure will be more because it's acted on one single body. It's like the like previous chapters, sir.
Okay. That is. See, yeah, will you imagine that if I say you that you can lift the car with just one finger if you put that in
Sir,
the
I
hole?
saw Mark Roberts video, sir.
If we were
Understood?
so strong.
He was
See, here what
putting that
happens? Pascal was a scientist. We'll study Pascal's law. Pascal's
Oh,
law.
pressure.
Pascal.
Pressure.
Sorry,
Okay,
sorry,
first we'll write it.
1 Pascal
Pardon?
is equal to
we already
2
learned
Pascal.
this.
No, that
No,
we
we
learned
didn't.
about the unit. This is Pascal's law.
We didn't learn Pascal's law. We didn't
Pascal's
learn.
law.
Pascal is a
we learned
person, Blaise Pascal.
Guys,
Blaise
Like
Pascal.
that
Newton,
is-
he's also an uncle.
Jobless
Date
uncle who
that.
wanted to find something.
Pascal's law still. So Pascal is the person who invented or discovered Pascal, right? So like the unit of term. This
Yeah.
guy.
He itself found it
Pressure,
and he itself named
pressure
it after
unit.
him.
It
That's
was
what
it
I
was
know.
after him.
Scientists can do that.
It was after him.
I just can't like believe that a person who named kilometer was named meter.
Even Fahrenheit
Named
is a
meter
person.
from here.
So, like, if possible, try using some other color while writing. Say, red is not that visible.
Okay.
Looks
I'll
like
not.
your
I'll
eyes.
change this color after this.
Sir, yellow is good, sir. Yellow is visible.
Yellow and blue.
I just wanted to make it more creative so that you won't find the writing parts boring. That's why I use different colors.
Yes, it
Oh,
looks
that's
much
very
better
cool,
if
sir.
you use many colors.
Yeah, that's biologically proven, sir.
Biologically proven.
Biologically, science.
What?
Green is
Yeah,
also
like you
good, sir.
see,
You never used
if you
green.
like, if you like, no, if you like,
So yes, sir, that's a
seeing different colors, our brain gets engaged. It's biologically
Says
proven.
who? Sankal.
It's actually proven,
Okay,
I'm
listen
not
here.
lying. Go check
Listen
Chrome
here.
right
What it
now.
says. What it says. See, I'll show you this with the hydraulic jack.
so you have a hydraulic jack in your home.
No,
I was like,
it's
what?
very
Oh, okay, that's a hydraulic jack.
expensive.
Sir,
Underestimated.
Wet
What's that,
water?
sir? Equally and
sir, I hate to bring like
undermined that.
tools again, sir. Sir,
Undetermined.
because I
What?
hated the I hated the first chapter because there were a lot of tools to learn, sir. So I don't like
No,
chapters
there
with
are
Lot
no
of
tools
what?
tools.
in them.
Calipers.
With a lot of tools in them, like all the vernier caliper, all that stuff. It's
See
very
here, see here.
confusing,
Oh,
sir.
Try to understand
hydraulic
things.
press
Try
is
to
not a
understand things.
tool, dad.
If you won't
But
understand
It's like
things,
a
you
what
machine.
will happen? You won't be able to get it. See here. Let us say this is A1 area, okay, and this is A2 area.
Okay.
Sir, it's
Uh,
just the width, sir.
hmm?
Yeah, it's
It's actually the
Sir,
breadth,
line,
it's
sir. How can you
2D
name
of
it area?
Tell you.
it's a it's a variable.
So you could have just drawn it with your pen, sir.
This square.
it's more accurate. It's more accurate.
So what happened here, everybody?
Yes, sir.
Sir, the black thing is a big box, right?
Oh my god.
Is nothing. That is no space. Okay. I just have this. Okay. This is the ground level.
Okay.
This is the ground level. Look.
This side
This
will
is the ground
be
level. And this is what you see in a hydraulic jack. Okay. There is a jack here. What happens? The person, the car is parked here in this platform. Let us say this is a platform. Right. The car is parked here. This is the car. And this is liquid. Okay, any liquid. Generally, it is taken as water. Right.
Water.
What happens here? Let us say this area is A1. This area is A1, and this is this area. This whole area that is there. This is A2. Okay. This area is A2. Now, let us say that what happened? The man applied F1 force here. F1 force here. And this force got transmitted from here to here by the liquid. See, liquid is incompressible. You cannot compress liquid. Understood? That is one thing. Always remember.
No,
Liquid,
but you
like
need a
you
lot of
compress
force
liquid,
to like.
see what happens.
So
What do
is
you mean
that
by
like
what do you mean when I say what do you mean when I say compressible? What happens? Uh, gases molecules. Okay, see, gases molecules are like this. Gases
the
molecules.
atomic atoms are like very far apart.
These are gases. Okay, these are liquid.
Liquids are a little bit closer by, and the solids are mostly packed together. Solids, that's why are very hard to compress because they are already
Okay.
close together.
So what happens? Generally, liquids are uncompressible. So what happens? See, gases, if you try to make them compact, so they can be adjusted here also. But liquid, you cannot compress it to more than this. Understood? So what happens? If F1 force pressure, the Pascal's law says
So
that
what
the
is that
pressure
black thing, sir?
black thing
Empty
is
space,
just
sir.
like it is blank. Then nothing is there. These are pipes.
Oh, okay.
This is
sir,
just
but how
perfect
can it
pipe.
Oh,
be like that, sir? Liquid always flows, right, sir?
Bruh.
This is a
Why
pipe.
you
Okay, this is
asking
a
that?
pipe. This is an interconnected
Filled
pipe.
to the brim.
Okay. Now see here.
Okay, it's an interconnected pipe.
Please listen here. So Pascal's law states that pressure travels undiscriminated everywhere. Okay. What happens? If you are applying pressure 1 at this point, so pressure 1 will be traveling to pressure 2 at this point. The same pressure will be, it's not pressure 2, it's pressure 1 only. Pressure 1 downwards, it will be pressure 1 upwards. Understood? So same pressure
Yes,
has to
sir.
travel. That is what like stated by Pascal's law. But you say that how much
So
pressure?
take another car and keep it on that.
Please, what difficulty are you having here?
Sir, we need F1, sir.
So what happens? You'll say that, sir, car is around, let us say, to 1000 kgs, around 1000
1 ton.
kgs. 1000 kg means how much force?
1
Force
ton.
required is 1000 into 10. That is
Yes, sir.
acceleration due to gravity, mg I am doing. So that will give you 10,000.
10,000 newtons, sir.
10,000 Newton force we require. You see, sir, how can we like provide 10,000 Newton force there? Okay, so let us say that this area is let us say it is 2 meters square. Okay, and this area is 1 centimeter square. Okay, 1 centimeter square, very less area. Or let us say that 10 centimeter square it is, that much you can take, right?
So 1 is like so small, sir.
Huh?
1 is like very small. There's no way we
I
can
took
do it
10
with 1.
centimeter square. 10
Yes, sir.
centimeter
10
square.
is fine.
So now see here, pressure 1 at this point, pressure at A, let us say this is point A, this is point B. So pressure at A should be equal to pressure at B by Pascal's law. So what is pressure?
Yes, sir.
F1 upon A1 should be equal to F2 upon A2, right?
Yes.
Yes, sir.
Everyone?
Yes, sir.
Now,
Yes, sir.
I need to get that how much force do I need to provide at F1 so that I can lift a car which is having a force of 10,000 newtons. So in that case, F1 I don't know. Area 1 is 10 centimeter square. Centimeter square, if you convert in meter square, how will you get? Tell me. What is 10
Into
centimeter square?
Sir.
5 by 18. Into 5 by 18.
That's
So
10
sir.
centimeter
We
square in
already
meter square I require.
0.1, sir.
0.
Not 0.1.
Oh wait, we have to
1
1 second,
centimeter
sir.
is 1 by 100.
0.001. 0.001.
1 centimeter is 1 by 100
0.01.
meter. So 1 centimeter
0.1
into 1 centimeter.
0.01.
1 by 100 into 100
0.001.
meter square.
Yes, sir.
Yes, sir.
Understood?
It's 1.001. 0001. My bad.
So 0 point
4 zeros.
0,
4 zeros.
01.
No.
4 zeros, 1.
3 zeros. Okay.
Zeros.
Sir, 3 0.
Sir,
Sir,
but
but
again.
there are 4 zeros, right, sir? So 100 into
there
100
are
is
4 zeros.
10,000, right?
10 centimeter square into meter square.
Oh, 10, it is 10, it is 10, it is 10. So, it is
Oh
not
yeah,
1
it's
centimeter, right? It's
already
10
10. Okay.
centimeter.
Is this correct?
Already
Yes,
Yes,
sir.
that's correct, sir.
Can you explain
How
how 100 into
how
100
do you do
is?
this calculation? You just have to divide with this. Sorry, got electric shock there. You just divide it with this 10, 100 into 100.
Yes, sir.
We are
Hmm?
converting 10 centimeter square, not 1.
Yeah, 10 centimeter
Yeah.
into meter square.
Yeah, that's why we don't include the 0.
So 1 centimeter
Understood?
square is 0.01.
I'll write here how much in 0.001 meter square.
Zero.
Agree, everyone? F2.
Yes,
What
sir.
is the force? What is the force that is being provided by the car? So that is 10,000.
10,000 Newton.
And what is the area
Newtons.
there? That is 2 meters square, right?
Meters.
Yes,
Agree?
sir.
Sir.
So see how much force it is there.
Yes.
So for 5,000 into 0.001, so that will be how much?
5.
30.
5
Sir,
newtons.
5 Newton.
F1 is 5. Sir, F1 is 5.
Just require
5
5
Newton.
Newton force.
No.
You know how much 5
What?
Newton is? You know how much 5 Newton is?
So it's
I
not
can do
Divide
it
by
by
acceleration
blowing, sir.
with the mass. Divided with acceleration due to gravity, you'll get the mass. How much will you get? You'll get
5,000.
0.5
Do that by
kg.
blowing,
What
sir.
is 5,000? So what is
Huh?
5,000, sir? What is 5,000?
10,000 divided by 5. 2 da. Come on, Sankalp. Use your brain.
5 divided by 9.8 or 10, sir? I think sir's network is gone. Hey,
Oh,
we don't
okay,
need
sir.
to do all this.
Oh, okay. So they said they send 0.001 meter square that side. Okay.
Come on, Sankalp. You can do this.
Sankalp's MOM is
Hope you can do this, by the way, but you
Sir.
do it. That's fine.
Sankalp's MOM is easier enough to do this.
Shut up,
Oh,
sir.
my
You're in a class which is being recorded.
Sir, can you hear us, sir?
Yeah, you're audible.
Hello, sir.
Okay.
You look too
Sir, you have to
old.
divide the force by gravity due to acceleration.
Can you see my screen?
Yes, sir.
Yes,
So
sir.
we have to divide
Yes,
force by
sir.
gravity due to acceleration.
So that's
See,
0.5
F1
kg of force that I have
is
to
5
apply.
Newton force. 5 newtons, let us say
Just
that
half
let's
kg
just
of
convert into mass. Please listen here, everyone.
5
Let's convert into
half
mass.
kg, sir.
So 5 is to mass into 10. Mass you get 0.5 kgs. That is 500 grams. So if you place 500 grams of object at the left hand side, you can lift a car.
If I
Isn't it?
place my computer, I can lift a car.
Exactly.
What is like 1 kilogram? Okay, no, not that heavy, but
Huh?
Understood?
So F1
Yes,
is
sir.
equal to 5n, which is equal to
I
mg.
just
So
took an example. I don't know exactly that whether the left hand side is 10 centimeter square or what. I don't know. Like, are you
but
getting my
sir,
point?
F1 on this
Yes,
side
sir.
will be the same as F1
Okay.
on that side.
So, but it should be less. It may be 20 centimeters square, 50 centimeters square, 100 centimeters square, doesn't matter. Are you getting my point? So what I mean to say is that
Sir.
at the left hand side, you need to keep as much small dia pipe as you can. And on the other hand side, you have to increase the dia as much as you can. And
Sir,
that
can
will
you go to
decrease
the
the amount.
previous slide for a second?
But during this we have to keep holding. We have to like keep giving the
Sir,
force, right? So else
There
it
is
will
a
stop.
stopcock here. There is a stopcock here. Okay, so what happens when you apply the force? Initially, this cock is
Come
removed.
back.
Okay, initially this cock is when the pressure is passed here. So they apply this stopcock here, and the pressure is now not allowed to come back.
But then it will be very hard to put that stop for damage, because
In
the
such
These
a small
particles,
time.
these
Oh,
materials which are
okay.
made, they are very strong. These
Okay, now
materials
I
are very
understand
strong.
why. Now I understand
Sir,
why
that
our
means
teacher
if I
didn't
if
take
I'm
this
in the
chapter.
middle of that hydraulic press, I'll get compressed to death
Yes, you will.
because I accidentally kept my laptop on that.
You lift a
Yes.
car if you accidentally keep a laptop on there.
Please
Go
don't
like,
take
let's
your
sit
laptop.
on this, you lift a car.
Please don't take your laptop to any kind of hydraulic press.
Sir, but to be fair, will I die if I
Nice
go
chair, let me
inside the
sit on it,
hydraulic
lifts
press?
car.
I don't know out of like where you got in your mind that you can take a laptop near the hydraulic press. Like, why is it required?
Because that's what is in front of
Experiment.
my eyes right now, sir.
That's virtual.
Sir,
Like,
so
will
if
I
we
die
like
if I'm in
decrease
the
the
middle of that?
button size to like nanometer, will we get more? Will it be even easier, sir?
It'll be
Most
harder,
easier, I think. Then if even if you pass some kind of air pressure, if you like do
Blow.
something like this, touching is enough to just throw a car upwards and it will go into space, something like that. Nanometers,
This
can
is
you imagine
so
that?
unpredictable.
So then why? So then like
Parts of-
why are like humans like aero scientists like the space
Sankalp with
scientists?
his
Why are they not
hypothetical
using
questions again.
femtometer buttons to push it and then send a rocket to
You know,
space
you
like
know
this?
how much pressure would it be there inside that pipe if you are increasing the level of a car to some extent, and that car is nearly about 1,000
Titanic
kg.
submarine.
What kind? How much strong that pipe would be? Can you imagine that?
So if you have to
This is
build
like
a
same.
rocket, it should be like you have to use the most strongest material in the world, and even then it's not possible. Rocket is like 20 times more heavier than a car. No,
Then you
wait,
have to
Jesus,
increase
200
it to
times
such an
heavier than a
extent.
car.
20 times, sir. Hey, it's like
200.
20,000. It's
You
like
know what is
2,000
escape
times.
velocity? You know what is
Yes,
Yes,
sir.
escape
sir.
velocity?
The
What is it?
velocity
Sir,
of
11,
the
7
rocket when
meters per
it
second.
escapes the
7
Earth's
kilometers per
atmosphere,
second.
and then it
Correct,
remains the
7
same
kilometers
because
per
it's in
second.
space.
What is that value?
No,
Sir, it's 7
So it can
kilometers
be
per
anything,
second, sir.
right?
Sir, it varies from 7 kilometers to 11 kilometers per second, sir.
No, it is exactly 11.2 kilometers per second. If you attain this velocity even once, you won't come back to Earth again.
No, sir, like until it reaches like the fifth layer of the atmosphere, it goes in 7 kilometers per second, and after that, it goes in 11 kilometers because that's when the
Escape.
liquid nitrogen is being
Exactly. So
released.
escape velocity is 11 kilometer per second.
he asked the escape velocity.
Okay, written everyone. Written everyone.
Yes, sir.
Yes, sir.
Yes, sir.
Half of the chapter is completed.
Sir, one
Go
second.
ahead. Huh.
So hydraulics is my favorite
So
topic in
crazy.
science. Actually, sir.
Half of the chapter is done. We'll be completing this chapter in next 2 classes.
Sir,
What I want from your side is that you just go at home and read this chapter again. Read the concept of hydraulic press. We have not done like total of the hydraulic press. Okay, you will be getting that principle, that working principle, and that working everything in the next class. I just explained it to you today. So we'll write these
Yes,
things,
sir.
Yes, sir.
then we'll solve questions. So practice the questions before that, and then we'll solve questions in the next class.
Yes, sir.
Yes,
Thank you,
sir.
sir.
Well,
Yes, sir.
So this chapter has a lot of numericals
I'll
in it.
talk to you. I'll talk about your this magnetism part with the administration. Okay. You even try to talk if you have somebody in contact with the administration. Try to talk with them. If they are fine, then I'll be available. I'm at home, so I can take extra classes. Presently, my
Yes,
colleges are not up. They'll be starting the next month. So I'm quite free, so I can take extra classes if they agree. It depends on them.
Yes, sir.
Thank you, sir.
Okay, sir.
Thank you,
Thank you,
sir.
sir.
Bye.
Sir, this chapter looks like it has a lot of numericals in its basket, sir, because
Why are you afraid
it's
of
just a
numericals?
lot.
Solve numericals. Solve more and more numericals if you're afraid of it. Then you'll find it
Ah.
easy. Don't run from anything. This is the start of your studies. 4 years you have to face the same thing. If you like get away from these things, they'll make you more scary.
Sir, sir,
Yes,
my
Tarun.
aunt, sir, my aunt was a professor of physics in IIT. She told that magnetism is the most hard chapter she has ever taught. It's so hard.
See, every chapter it depends on the relativeness, what you feel. Okay, there may be the things, conditions like if you are feeling a chapter to be easy, some other people will be finding it hard. Okay, you must have experienced it even
Sir,
earlier.
you're saying that hydraulics is an easy chapter, but I'm feeling it hard. But you said laws of motion is a hard chapter, but I'm feeling it easy, sir.
Exactly. So it depends on the people. If you work on it, really work on it, so you'll get everything easy. Okay. If you really work on it, you'll get everything easy. Everything is hard, everything is easy, depends on your work. Okay.
Yes, sir.
Earning lakhs
So
and
the
crores of
only
rupees.
new So the only new word I learned in the laws of motion chapter is inertia, sir. Rest all I already know. But in this chapter, it's not even quarter done, but I learned like 5 new terms, sir.
Focus. I'll try to make everything easy for you, but please solve it at home. If you don't solve it, if you run up from it, nothing will be easy for you. Okay, then, bye.
Bye, sir.
Yes, sir. Thank you, sir. Bye, sir.